A lot of times you see in movies and whatnot, they'll try to heat something up, boiling water, put the instruments in boiling water, you know, or, heat it up next to the fire or things like that. What you have to keep in mind is, as we talked about in the last lecture, whatever methodology you're using for the heat, it has to be high enough temperature, high enough pressure, and long enough time to actually damage and kill. Turns out, many microbes have some levels of heat resistance in them. If you're talking dry heat, that extended long periods of time, that'll kill pretty much everything. If you're heating it up constantly for 10 hours straight at such a high level of heat. When it comes right down to it, very few things can handle being in an oven at relatively mild temperatures like 120 to 1 degree Celsius for 10 hours. It's going to start to damage. It's going to start to warp metals, plastics. And at that relatively mild temperature for that extreme amount of time, yes, the vegetative cells are going to be killed, but the endospores, don't know. It's going to take time. And you have to take into account that thermal death using heat, whether it's dry heat, moist heat, well, all microbes are going to, react differently depending upon what species. The examples your book uses, Neisseria gonorrhea, yes, the one that causes STDs. You heat up whatever it's in 50 degrees Celsius for 3 minutes. 50 degrees Celsius, that's about 150-ish degrees Fahrenheit. Heat it up for 3 minutes. Neisseria gonorrhea, dead. But on the flip side, close to that same temperatures, well, you're going to have to heat it up for about an hour to kill Staphylococcus aureus. If you're also, worried that there may be some viruses present, well, different temperatures, different time lengths for the different, viral strains. These are all things that have to be taken into account when you're trying to determine what method to use to sterilize, to decontaminate. So what we've done, we microbiologists, to help out our clinician friends and, the people who are there for, hospital safety. We microbiologists in the lab have studied microbes. We've looked at things like the thermal death time. What's the shortest amount of time you have to heat something up to kill the most microbes? This is the amount of time you have to heat, to kill 50%. This is the amount of time you have to heat to kill 75%, 100%. We also sit there and at the same time are calculating what is known as the thermal death point. What's the lowest temperature at the shortest amount of time? So that way we can do, the death time and the death point together. Yeah, you crank up the heat, death time's going to be short. But the problem is, can whatever it is you're trying to sterilize, you're trying to decontaminate, handle that extreme heat? Is it going to melt? Is it going to warp? Is it going to somehow delaminate plastics, metals? It's going to interfere with electronics. Well, instead of, cranking it up to, 180 degrees Celsius, can we turn it down a bit, the temperature down, and get away with 130, 140, 120? If we turn down that time, temperature, how much time are we going to have to add onto the clock? Death time, shortest length of time, death point, lowest temperature. It's a balance. Higher the temperature, lower the time. But the higher the temperature, the greater the chances of damaging whatever object, whatever instrument you're trying to decontaminate or sterilize. So if you lower the temperature, you have to increase the time. It's a nice balance.